Welcome back. Dear friends, today we are going to solve problem 5.8. So, in this problem, it is given that draw the shear and bending moment diagram for the beam and loading shown. Determine the maximum absolute value of shear and bending moment. So you can see this is a cantilever beam that is fixed at point A. There is a loading at point C, 200 at point T, 200 Newton at point E, 500 upward, and at point B there is a load of 200 Newton downward. All the dimensions that are given in millimeter, and the total length is 300 plus 225 plus 300 plus 225. So let's start with the solution. As we know that this beam is cantilever beam that is having at end A is fixed support. So if you replace this fixed support, so definitely there will be a reaction force which is represented R as RA, and there will be a moment that is represented MA. So RA and MA is not known, are not known, so we'll apply equilibrium condition in order to find this unknown reaction forces and moment. So let's move. So what we will do is that we will apply equilibrium condition. So first condition is that sum of all forces along y direction must be equal to 0, taking upward force as positive. So you can see one force is RA, that is upward. So RA, the second force is this one, 200 minus 200, that is downward. The third one is also 200, which is downward, minus the plus the fourth force is plus 500, and the other one is minus 200. So their sum must be equal to 0. So it means that RA is equal to 600 minus 500, which is equal to 100 Newton. So RA should be 100 Newton. Now we'll apply the second moment equilibrium condition, that sum of all moment about point A is equal to 0, and taking the counterclockwise moment is positive. So at point A we have this clockwise reaction moment, so this will be minus MA, or a moment about point A. So this MA is the reaction moment. Okay, so MA, the second moment at point A, is due to this force at point C. So it will be 200 into perpendicular distance is 300, and that is producing clockwise movement. Clear? So it will be minus the other movement that is produced due to this load 200. So 200 multiplied by perpendicular distance is 525. You can see 300 plus 225, and it is also minus the fourth movement that is due to 500, and it will be counterclockwise, so it will be taken as positive. So plus 500 into perpendicular distance is 300 plus 300 600 and 225, so 825, and the last one is 200 into whole perpendicular distance. So minus 200 into perpendicular distance is 300 300 600 825 850 1050. Their sum must be equal to 0. So when you calculate it, definitely you will get reaction moment at point A, which comes out to be 37.5 Newton into meter. So assume that it means that our direction which we have assumed clockwise is wrong. So it should be counterclockwise movement in order to keep the balance. Okay, now we have these reaction forces. We will move to draw the shear force and bending moment diagram. For that, again, I have to delete these things. We will move forward. Okay, so first what we will do is that we will section the beam at this point. We will section the beam at this point. So when you section the beam at B or just away from B. So what we will see that this is point B. Here the load was 200, clear, and from B to E the distance is given as 225. You can section the beam from B to E anywhere. Okay, so when you cut the beam, so definitely there will be a shear force V and there will be a reaction moment M. Now we will apply equilibrium condition that we will apply equilibrium condition. Okay, so at point B, just at point B, if you cut this beam over here, so if I draw it over here, I will, if you cut the beam over here, so definitely you can see at point R, at point B, we can just take that at point B, we know that the shear force is equal to 200 Newton and moment is 0 at point B. Now at point E plus. Now what does E plus means? E plus mean that you can section the beam at point E but just before the point E, not at point E exactly, just slightly before the point E. Okay, so when you cut it, so what will you have? The beam like this is point B where 200 Newton load is applied. The distance from B to E is 225, and definitely when you cut it over here, so there will be a shear force V and there will be a reaction moment M. Now we apply equilibrium condition. Sum of all forces along y direction must be equal to 0, taking upward force as positive in order to find this shear force V. Okay, so you can see there V is upward, so V is positive minus 200 Newton, which is acting downward, this one. So their sum must be equal to 0. So from here you can get V is equal to 200 Newton. So this is Newton. We will apply the moment condition. Sum of all moment at this point E. Let this is the point E. So at point E must be equal to 0 and taking the counterclockwise movement as positive. So at point E there is a movement M that is clockwise, so minus M, and due to this load of 200 Newton, so 200 into perpendicular distance is 225, and it is producing clockwise movement, so it will be also negative. So their sum must be equal to 0, and when you calculate it, this moment will be minus 45 Newton into meter. Now we'll section the beam at D plus. Now D plus means up till point D but not exactly at point D. So we have the diagram over here as well. So at D plus, when you cut the beam, so definitely you have to draw the beam. This is point B where 200 at point B 200 Newton loads is applied. At point E we have upper 500 Newton load. The distance between these two are 225, and from this is B point, sorry, not B, this is E point, this is your B point, and distance from B to D, D is somewhat away from this line, so this distance is 300 millimeter. Okay, so when you cut it, so definitely you will have a shear force and reaction moment. Now we'll apply equilibrium condition that sum of all forces along y direction must be equal to 0 and upward force are positive. Now three forces V 500 Newton and 200 Newton. So V is upward, so plus 500 is also upward and minus 200 is downward. Their sum must be equal to 0. From here V will be equal to minus 300 Newton. So this is for at point D. Now we'll apply the sum of all moment about point D must be equal to 0 and taking the counterclockwise moment as positive. So at point D we have a external moment that is clockwise, so it will be negative. The other moment is due to this 500 Newton load and the perpendicular resistance is 300. So 500 into 300. These are in millimeter. Okay, so this is producing counterclockwise, so it will be positive. And the third moment is due to this 200 Newton load, so 200 into perpendicular distance is now 525. That is minus. Their sum must be equal to 0. So when you solve this and if you convert these millimeters into meters, so you will get the answer 45 Newton into meter. Now we have left the third portion, that is C plus. So we will cut the beam at C plus. For that I have to move away to the next page. So we'll move toward the next page, and at C plus what we have to draw is we have to draw the beam again. So this is point B where we have load of 200 Newton. This is B. This is point E where we have 500 Newton upward. This is point D where we have again 200 Newton. Clear? This is point D and this is point C. So from B to this distance is 225. The distance between D and E is 300, and same distance between C and D are 225. Okay, so at point C we will have a shear force and reaction moment as well. So we will apply sum of all forces along y direction must be equal to 0 and taking upward force as positive. So V minus 200 plus 500 minus 200. Their sum must be equal to 0. Now when you calculate it, you will get V is equal to minus 100 Newton. Similarly, sum of all moment about point C must be equal to 0 and taking the counterclockwise moment as positive. So at point C we have this external moment M, which is minus clockwise. One moment is due to this load, so 200 into perpendicular distance is 225, that is clockwise. The other load moment about point C is due to 500, so 500 into perpendicular distance is 525, and that is counterclockwise, so it will be positive. The other moment is due to this load, so 200 into perpendicular distance is 225. 225 is 450 and 300, so 750. and that is clockwise. Their sum must be equal to 0. So when you solve this, you will get moment about point C comes out to be 67.5 Newton into meter. Again, you have to convert this into millimeter into meter, then you will get this value. Now we have all the values at point C. We can see that we have shear force at and moment at point B, similarly at point E plus, at point D plus and C plus. Now we can plot them uh, to get the shear force and bending moment. Okay, so for shear force I have drawn the graph and all the points are mentioned over here, you can see. So if I plot it, if we plot it, so you can see that point B we have at point B we have 200 Newton load. So let one division is equal to 100. Clear? So sorry, one division here we will take one division is equal to 50. So 200 will be 4 divisions. So B point will be, this is 200 Newton. At point E plus E or E plus, we have a load of, where is E? This is, we have a load of 200. So it will remain 200 till point E. Okay. At point D plus, we have okay, so we'll again, you have to start from the left. Okay, so we'll start from A. So we know that at A we have 100. So 100 is, this is 50, this is 100. So one point is this one, this is 100. And from moving from A to C, the load, you can see there is no load. Clear? So it will, at till point C it will be same 100. But at point C you can see that at point C we have load that is minus 100. Clear? So we will plot them. At point C we have minus 100, which is because minus 100 because the load is now changing. At C we have 200. So 100 minus 200 is minus 100. Clear? Now from C to D you can see the load does not change, but at point D we have again a load of 500 Newton. So minus 100 and 300. It will go to minus 100. Clear? At point, let me check, point D we have 200 Newton load, sorry. So 200 and minus 100 is minus 300. So this will be 200 and this will be minus. So this point is minus 300. I will write it minus 300. So from D to E again we do not have any load, so it will remain the same. But at point E we have 500 Newton load. Clear? So minus 300 plus 500 will be 200. So we will get this point. Again, if you join them, I will show you, you will get the shear force diagram. So from A to C it is a constant line, because from C to D again this is a straight line. From C is no, sorry, vertical line. From C to D it is a horizontal line. From C to D it is a horizontal line. I don't know why this is giving such. From C to D it is horizontal line. Similarly from D to, there is a vertical line, and from D to E this is horizontal line. Okay, now from D, from point E load changes from minus 300 to 200. So we will go straight, and again from E to B we have a horizontal line. So this is your shear force diagram. Now we'll move toward the bending moment diagram, and in bending moment diagram we take one division is equal to 25 Newton into meter. Here one in shear force we have one division is equal to 50 Newton. So on y-axis, okay, so one division is equal to 25. So at point A we have 36, at point A we have 37.5 Newton. So this is 25 and this is 50, so 37 will be somewhat here. At point C we have 67.5, so 67 will be, this is 50, this will be 67 will be somewhat here, not approximately but it will be here. At point D you can see we have 45 Newton, so this is 25, so 45 will be somewhere here. Okay, at point E we have minus 45, so minus 45 will be here because this is 25, this is 50, so minus 45 will be somewhere here. And again at point B we have moment is equal to 0. Now you can join them. So from point A till point C we have this line, because you can see the shear force is 0 degree, constant line or having 0 degree, so moment line will be first degree. Now from C to D you can see loads are changed, and we have plot, so we just will move toward this, we will just join them. Similarly from D to this point you can join them straight, these 2 points. And from E to P, straight line. So this is 62.5, this is 45, this is minus 45, and this point is 37.5. So this is the way where we can draw the shear force and bending moment diagram. Now in second part it has been asked to find the maximum absolute value of shear and bending. So from here, from shear force diagram, you can see the maximum value of shear force is 300 Newton, and similarly from here the maximum absolute value of bending moment is 62.5 Newton into meter. So this was all about problem 5.8. I hope you have enjoyed it, and if you like my videos and you haven't subscribed my channel, so then subscribe it now and keep watching. Thank you.